So let's go ahead and do that now. We are going to relate implication back to some of the logical operators that we've already seen. So in particular, I'm going to make the following claim. And this claim is P implies Q is logically equivalent to not P or Q. That these two expressions are logically equivalent. So how am I going to prove that? Well, to be able to prove that, this claim right here is saying that these two expressions are logically equivalent. And so what I have to do is show that they have the same truth table no matter what values their underlying variables take. So both of these have P and Q in them. So I'm going to go ahead and write down my truth table for both this expression on the left-hand side and this expression on the right-hand side and see whether or not the truth tables are the same. So let's go ahead and do that. Well, thankfully, this part of the truth table is going to be really easy to fill in because we already have the definition up here. We already know that this is true, false, true, true. So all I have to do is fill in this part of my truth table. So once again, I'm going to do a bit of scratch work on the side to help me to simplify this particular expression right here. So let's look at the first row in this table. So here P is true and Q is true. So this particular expression at this part is not true or true. So here the not flips it, so it becomes a false or true. Well, false or true we know is true. So I can go ahead and fill in this part. This is true. Here, P is true, so we have not true or, but Q is false, so this thing is going to become false or false. And if you remember the definition of or, this right here is going to be false. So I can fill in a false right here. And then for this row, I have ending up with a true or true, and this thing is going to be true. So filling in that row, I get a true. And our very last row, let's see if we can complete our proof. We get P is false, Q is false. That becomes a true or false. Haha, at least one of them is true, so that becomes a true. And yes, indeed, we have a true. And unless I'm horribly mistaken, every single one of these match. So yes, indeed, this part of the truth table and that part of the truth table are exactly the same. So by the definition of logically equivalent, P implies Q is logically equivalent to not P or Q. So this is basically all I need to be able to prove that these two expressions are the same. So I can do a little QED box at the very end right here saying, yes, these two expressions are true. So yes, these are true. Well, why was it important to be able to show that these two are logically equivalent? Well, it turns out in some circumstances, it's a whole lot easier to think of P implies Q as this expression right here, rather than using that definition up there. So if you recall back in our example that we had earlier, so if you recall, we had an example that read something like, P is the sky is always purple, and Q is everyone has $1 million. And you remember that trying to figure out if P implies Q, it was a little bit confusing, right? To try to figure out whether that statement right there is true or false. But now we know that this is logically equivalent to not P or Q. So if we think about it in this case, well, in this particular instance, we have this statement on the right-hand side reading, the sky is not, because it has the not right there, always purple, or everyone has $1 million. And personally, I think that's a lot easier of an English sentence to determine its truth value of, right? The sky is not always purple, or everyone has $1 million. Yeah, that's true, of course. Why? Because the sky is not always purple. And or only needs either this statement or that statement to be true. So of course, we know that this thing is going to have a truth value of true. And that shows you some of the power behind logical equivalence, because it can take an expression and rewrite it in terms of another expression that in certain instances, like this example right here, make it a lot easier to interpret and understand.